looking at the remainder and factor theorems. Our first problem. Find the quotient and the remainder when this quartic is divided by the linear expression x plus 2. So I'm looking at this. If I do that on my CAS calculator, I'll get the quotient here, the remainder, and that divisor. So what's really interesting for us is that we're dividing by x plus 2, and when we do so, we get a result, or a remainder rather, of 40. Let's now take a look at substituting negative 2 into this quartic and see what it produces. So I've got my p of x, that's the quartic. I'm now subbing in negative 2 into that polynomial, and the result is 40. And this isn't a coincidence. So I've got 40 here, and the remainder is 40. And this leads us into the remainder theorem. So if we've got p of x, if it's divided by x minus a, then when we evaluate p of a, that will be the remainder. In the same way, if I've got the polynomial p of x, and we divide it by some linear factor where a is unknown, so let's call it ax minus b, then the remainder will be equal to the substitution of b on a into that polynomial. How did I get b on a? I take what's inside this bracket, make it equal to 0 and solve for x. And you can see there that that would be equal to b on a. Same thing applies here. I've got x minus a, I make it equal to 0, I solve for x and I get x equaling a. So it's that substitution that we put into the polynomial, and that will provide us with the remainder. Let's look at an application of that. Problem 2. Find the remainder when this cubic is divided by 3x plus 2. So I get 3x plus 2, make it equal to 0, solve for x and get negative 2/3. So according to our theorem, if I substitute negative 2/3 into the polynomial, it should tell me what the remainder is. And there it is, 1. I could verify that on my CAS. I challenge you guys to do that now. And you could also perform long division on it. But clearly, if we're just interested in the remainder, we can apply that remainder theorem. It's nice and easy for us to work out what the remainder will be. Another application. I've got this cubic with an unknown constant c at the end. I know when I divide it by the linear factor x minus 2, the remainder will be 30. What is c? So p of 2, substituting 2 into that cubic, produces 30, and that will equal 2 cubed plus 3 lots of 2 squared plus 3 lots of 2 plus the unknown constant c. Working through the algebra, you can see that we end up with c equaling 4. We're now going to talk about the factor theorem, and this is where the remainder theorem becomes really useful to us. If the substitution of a into the polynomial produces a 0, then what we can say is x minus a must be a factor of p of x. Let's look at the application of this. Here we've got a. Find the linear factors of p of x, where it's equal to 2x cubed minus x squared minus 13x takes 6. So what I'm going to do is just randomly plug in some numbers into p of x and see which one produces a 0. If I get a 0, then I'm able to identify a linear factor. So firstly, I'm substituting 1 into it. And you can see it produces negative 18. I then substitute negative 2 into the polynomial, and it produces 0. Therefore, I can say that x plus 2 must be a factor of this polynomial. That is, that when we take this cubic, and divide it by x plus 2, there is no remainder. Let's look at long division of this. So here's my cubic. I'm dividing it by x plus 2, and you can see I can work through everything, and you can see here that I have a remainder of 0. So what am I able to say about this? That when I have that cubic divided by x plus 2, I'll end up with this quadratic here. Now this is a quadratic, and I can factorize in whatever way that you like, PSF, or you can use the grid method. And you can see we're able to identify what the linear factors are here. So it's going to be 2x plus 1 in the first bracket, multiplied by x minus 3 in the second bracket. So overall, I've achieved a lot. 2x cubed minus x squared minus 13x take away 6 is equal to x plus 2 multiplied by this quadratic. And then that quadratic can be factorised as well. So what I have is that this cubic, when completely factorised, is equal to x plus 2 multiplied by 2x plus 1 multiplied by x minus 3. Being able to factorise cubics and quartics is extremely handy for us, because what we're able to do is solve cubic equations, and we can use this knowledge to help us when we graph as well, as far as turning points are concerned and intercepts. So it's got a really strong application to what we'll do later on with our mathematics. Let's take a look at B now. I've got another cubic. So again, I try substituting different numbers in. Now, of course, you're not going to get one of these plain simple numbers, a number between -3 and +3, is always going to work out for you on the problems that you're presented with. You're not going to be required to plug in something like 7. So start with 1 or -1 and then work your way out. So 2, -2, 3, -3, until you work out one of the factors. So in our case, I'm trying -1, it produces a 0, so I can conclude that x plus 1 must be a factor. I set it up for long division. And you can see that there's my cubic, that's what I'm dividing by. I perform long division, I have a remainder of 0, so that confirms that I've done everything okay. And when I divide that cubic by this linear, I end up with this quadratic. Again, you can see these steps here. And now we have the factorization. So this here can be factorized to become x take away 3 multiplied by x plus 2. Overall, this cubic becomes that. For C, here's our polynomial, another cubic. If I substitute 1 into this particular polynomial, I'll get a 0. Therefore, I can say that x minus 1 is a factor. Again, long division, there's my cubic. I'm dividing by x minus 1, and I get a remainder of 0, and that produces this quadratic. So this cubic divided by that linear produces this quadratic, and I can factorize that quadratic to be x plus 2 multiplied by x plus 1. And what do I have overall? This cubic becomes x minus 1 multiplied by x plus 2 multiplied by x plus 1. Explained before, we can also use our CAS to find the linear factors. So here's an example, p of x equals this particular cubic. All I need to do is go menu, algebra, factor, place in the cubic, and it'll produce the factors. In problem 5 here, we just need to verify the answers that we found to problem 4 using our CAS. I'll demonstrate A. So menu, algebra, factor, and I'm going to put in the cubic. So it's 2x to the power of 3 minus x to the power of 2 minus 13x take away 6. And there's my linear factors listed here. So very easy to do. This next little section around problem 6, to be honest with you, I'm not a real big believer in. But I'll take you through the process, and I think you'll agree with me in the end that long division is a better way of factorising. All we're going to say is that if we've got a certain polynomial, a cubic one, if I work out the substitution of an unknown w into it and I get a 0, then what I can say is that this polynomial p of x can be written as x minus w multiplied by some quadratic we'll refer to as being ax squared plus bx plus c. Let's look at factorising this cubic. I substitute 1 into it and it produces a 0. So what I know is that x minus 1 is a factor of f of x. Notice how I set this up now. Here's my cubic in expanded form, and I've got x minus 1 multiplied by an unknown quadratic referred to as ax squared plus bx plus c. If I now expand the brackets, you can see x times that, x times bx, x times c, then negative 1 times that, negative 1 times bx, negative 1 times c. And there's the expansion of it. If I collect like terms, I'm able to write this cubic in this format, involving b's, a's, and c's. Why? Now what I can do is equate the coefficients. So 3 is going to equal to a. So I know that a is 3. 4 is going to equal b minus a. And I can now go through, substitute negative 3 into it to produce that b is 7. I can also work out that negative 13 is equal to c minus b, and going through doing the algebra, I'll produce that c is equal to negative 6. And finally, that 6 must be equal to negative c. So that 6 is equal to negative c, producing c equaling negative 6. Phone now. Let's conclude. So what we're able to say is that this cubic is equal to x minus 1 multiplied by the quadratic 3x squared plus 7x minus 6. I'm sure you agree with me that a better way of doing that is to perform long division, but I have shown you. Alright, now we're going to be looking at the sum and difference of two cubes. You'd be familiar with the difference of two squares rule, but here we've got the difference of two cubes. These are the rules. Let's look at the application of them. So for a, I've got x cubed plus 8. I recognise the x is the a, and I recognise that the 2 is the b, and it's the addition, so it's the sum one that we're using. So I end up with x plus 2 in the first bracket multiplied by x squared minus 2 lots of x plus 4. Done. B. We've got y cubed minus 216. Y to the power of 3 minus 6 to the power of 3. So 216 can be written as 6 cubed. So here we're going to be applying the difference of two cubes. So it's y minus 6 in the first bracket, and then I have y squared plus 6 lots of y plus 36. C, I've got 4a to the power of 4 plus 4a. So I begin by taking 4a out. I now recognise that I have a cubed plus 1 cubed. So I've still got my 4a. I've got a plus 1 here, multiplied by a squared minus a plus 1. And for D, I've got two lots of x plus 6 cubed plus 16. I take 2 out as a common factor for everything. I now rewrite it, so it's the addition of two things cubed. So it's x plus 6 cubed, and it's 2 cubed. 8 is the same thing as 2 cubed. Going through, I've got two lots of x plus 6 plus the 2, and then I've got x plus 6 squared minus 2 lots of x plus 6 plus 2 squared, at the very end there. Obviously, tidying up that first bracket produces x plus 6, and you can see here that I've expanded out x plus 6 squared, so it's x squared plus 12x plus 36. And now I've taken negative 2 and multiplied it through x plus 6 to get negative 2x take away 12, and I've squared the 2 to get 4. Tidying everything up, collecting like terms, it's two lots of x plus 8 multiplied by x squared plus 10x plus 28. So when you go back and try to memorize these rules, here we've got the addition of two cubes. So the first bracket is just a plus b. Then, because it's a plus, think of this part here as being the opposite of it. So it's minus. So it's a squared, the first part, minus ab, so you multiply these two together, plus the second part squared. And here for this subtraction, then we've got a minus b, and we've got a squared plus, so it's the opposite, ab, plus the b squared at the end. That's the best way of memorizing the sum and difference of two cubes rules.